Got to give the people, what they want. Woo! Vocals. All right, Mr. Bass, we are in section 2.4. We are talking about complex conjugates and rationalizing the denominator. Okay? So, the complex conjugate is like the opposite version of a complex number. I don't want to give you the like crazy definition, but that's kind of the simple definition. So for example, right? If I have 6 minus 4i, that's a complex number. All right, it's a complex because it has a regular number, 6, and an imaginary number, 4i. So that's a complex number. If 6 minus 4i is a complex number, then its complex conjugate is 6 plus 4i, right? It's like the opposite version. 6 minus 4i, 6 plus 4i. Let's do another example. Another complex number, negative 8 plus I. That's a complex number. So its complex conjugate would be negative 8 minus I. That's the complex conjugate. Third example, if we have the square root of negative 19, I got to write this in standard form, right? So the square root of negative 19 is negative 19i. That's the complex number, right? Because that's the square root of that's the square root of 19 times negative 1. Square root of negative 1. So that's where I get the 19i. So the complex conjugate of that is really, that's kind of like 0 plus square root of 19i. So the complex conjugate is 0 minus square root of 19i. And that's easy, right? So really, it's just negative square root of 19i. Okay? Oh, why does that keep erasing? So that's just the negative square root of 19i. This is the positive version of it, and that's the minus version of it. This would be the complex conjugate. All right. So why do we use complex conjugates? We use complex conjugates to simplify fractions with imaginary numbers in the denominator. That's called rationalizing the denominator. Denominators of fractions can't contain imaginary numbers, just like denominators can't be 0. That's just one of the things you can't do when you're simplifying. So we have to figure out how to get rid of the imaginary numbers in the denominator of fractions. So, when you multiply a complex number by its conjugate, you'll end up with no more imaginary numbers. That's really the key. So let's talk about how to do this. Boom. Boom, boom. First, let's go ahead and see what happens when you multiply complex numbers with this conjugate. So here's a complex number, 8 minus 5i. Here's its conjugate, 8 plus 5i, right? So we're just going to talk about this part. So if I multiply those together, look what happens. Actually, why don't you do it? Do the area model, multiply those together, please. Pause it right here and make that happen. Cool, you did it. 8 minus 5i, 8 plus 5i. This is 64. This is 40i. This is negative 40i. And this is negative 25i squared. Look what happens here. The negative 40i and the positive 40i cancel out. You end up with 64 minus 25i squared. Except, we know that I squared is equal to negative 1. So you end up with 64 minus 25 times negative 1. Right? Which, actually, let me move some stuff around here. Move this down a little bit more. Which, if we go ahead and keep simplifying it, it's 64 minus, what's negative 25 and 1 is plus 25. That's not a 5. Plus 25, which is whatever 64 plus 25 is, 89. See, so notice when I multiplied the complex number here by its conjugate here, I ended up with the number 89. I lost my imaginary numbers. Let's see what happens again on part B. So here's my complex number, square root of 31i. Here's the conjugate, the negative square root of 31i. So let's see if we multiply those together. So actually, let me not do it that way. So it's the square root 31i times negative square root 31i. So I end up with, notice that this has a 1, so I end up with 1. This has a negative 1 times a negative 1. I got to multiply those together. I end up with the square root of 31 times the square root of 31. And I end up with I times I. Hopefully you can see where all those things came from. Well, 1 times negative 1 is negative 1. The square root of 31 times the square root of 31 is the number 31. And I times I is I squared. And what do we know? Negative 1 is still negative 1. 31 is still 31. And I squared is negative 1. Like, that's the key. We get those I squareds and we start getting rid of imaginary numbers. So this is 1 times 31, which is negative 31. So we have negative 31 times negative 1, which is finally an answer of actually 31. So we can see how when I multiply the complex number times its conjugate, I end up getting rid of, what are these called? The imaginary numbers. So let's do one more piece. Write the quotient in standard form. Again, you can't have any i's in the denominator. Use the complex conjugate to support you in doing this. So we're going to take 8 divided by I, and we're going to use complex conjugates to help us get rid of the I in the denominator. So let me move this over. Okay, so I can multiply a fraction by anything that's equal to 1 without changing it. So if I wanted to get rid of this I down here, I'm going to multiply it by its complex conjugate, which is negative I. But if I need to take this whole fraction and make it equal to 1, right? Because that's the only way I can do this with fractions. I'm going to have to put it negative I over negative I, because that equals 1. So this is a big old fraction that is equal to the number 1. And I'm using negative I as the complex conjugate. So what do I get? On the bottom, I get negative I squared. And on the top, I get 8. Actually, I get negative 8i. Right? This is negative 1i, so that's negative 8i. Alright, so now I'm going to go ahead and simplify. I get negative, and then I squared is negative 1. And at the top, I just have negative 8i. And finally, at the bottom, I end up with negative negative 1, which is 1 over negative 8i. Right, so my final answer is actually negative 8i. I rationalize the denominator. That is called rationalizing the denominator. Okay, and I've also now written it in standard form. Again, standard form can't have any imaginary numbers in the denominator. Let's do this one more. I have 6 over 2 minus I. So I got to get rid of this I at the bottom, so I'm going to multiply it by its complex conjugate. So I'm going to do 2 plus I over 2 plus I, because remember, this is just a fraction that is equal to 1. So multiply these out. Let's see, let's do 2 minus I times 2 plus I This is 4. This is 2i. This is negative 2i. And this is negative I squared. Negative 1i squared. Right? Negative 2i and 2i cancel out. 4 is just 4. Negative 1i squared is negative 1 times negative 1, which equals 1. Right? So end up with 4 plus 1, which is just the number 5. This is 5. And then at the top, up here, I got to multiply b, or is that b? 6, excuse me, times 2 plus I. So let's go ahead and do that. 6 times 2 plus I, which is 12 and 6i. So that's going to be 12 plus 6i over 5. Now this is simplified. This is the introduction. This is what you need for class tomorrow. We'll have time to work on it. Mr. Bass, I'm out.